Today we're going to be talking about finding measures of similar figures. Let's revisit first what similar figures are. Remember, similar figures have the same shape but not necessarily the same size. Your corresponding angles are congruent, meaning they're the same measurement. And your corresponding sides form equal ratios. I'm telling you that triangle ABC is congruent to, or is similar to, I want to change that, is similar to triangle DEF. Since I'm telling you that triangle ABC is similar to triangle DEF, I know that my angles are the same and that my sides are proportional. They form equal ratios. Since I know that they are similar, I can easily find the length of a missing side by setting up a proportion. All I have to do is make sure that I'm using corresponding sides. Remember, when you set up a proportion, you want to have like things together. So, if I choose length AB for my numerator in my first fraction, then I'll want to choose BC or AC for my denominator. Well, since I'm looking for EF in the other triangle, I want to make sure that I choose the same side that goes with the X in my first triangle. So that means I need to use the 10. The 12 would do me no good because I'm not looking for the corresponding side to AC. Notice that AC would be the same as DF. I'm not looking for that measurement. I'm looking for the corresponding side, the matching side to BC, and that is EF. Okay, remember, we have to have like things together. So this is my first triangle. So my second ratio is going to be from my second triangle. Well, I also have to match going across. So since I chose the 15 for my numerator, that's length AB, I need to choose the matching side from the second triangle. That's going to be DE. So that means my top number over here must be a 12 because they have to be matching sides. And that leaves me to put in the X, and it's the matching side to 10 from the second triangle, or from the first triangle. So again, first triangle, second triangle, matching sides here, and matching sides here. So now I'm ready to go ahead and solve this proportion. And we'll do that by cross-multiplying and then dividing. Let's see how that works. Okay, I know that 10 times 12 is 120, and that's going to be equal to 15 times x, which is 15x. I want x by itself. 15 is attached to x through multiplication, so to undo, I must divide both sides by 15, the number I'm trying to get rid of. My 15s cancel out because 15 divided by 15 is 1, and 1 times x is x, which is what I want. And now I just simply need to divide 120 by 15. And I'm going to find out that x is equal to 8. So my missing side length here is 8. Okay, so let's try this again. Again, we're using proportions to solve for missing sides. I'm telling you that PQRS is similar to TUVW. That means all of their angles are the same size and that their sides are proportional. So I'm going to use a proportion to figure out what the missing side A, B, and C are. I can only do one side at a time, and I have to have 3 numbers and 1 letter. It will do me no good if I have 2 letters to solve for. I can only solve for 1 letter at a time. So that means I must use the 12 as one of my numbers for my ratios. And if you'll notice, TW is the matching side to PS. So that means I'm also going to need to use this 8 when I set up my proportion. So let's go ahead and solve for A. I'm going to use 6 over 8. And that is going to be equal to A over 12. Now why does that work? Well, 6 and 8 both come from the first shape. A and 12 both come from the second shape. 6 and A are corresponding sides, and 8 and 12 are corresponding sides. I have my proportions set up correctly. Now it's just a matter of cross-multiplying and dividing. So here I have 8 times A, which is 8A, and that's going to equal 6 times 12, which is 72. That means side A is equal to 9. So if I wanted to, I could come up here and replace A with a 9. Now I could use this number to solve my other proportions or my other side lengths as well. The danger in that is if I have a mathematical error here, then it will throw off my other numbers as well. So I encourage you to always go back to the number that was given so that you don't accidentally make that mistake. So let's go ahead and set up another proportion. Let's go with, I need B or C. Let's go with B. So that means I'm going to have to use the 12 from the first shape. So I'm going to go, and because I want to use this 12 as well, that means I need to use the 8 as well. So let's go with 12 over 8. And we will say that that is equal to, if I have a 12 on top here, we'll go with B over 12 on bottom. So let's make sure that this works. 12 and 8, 12 and 8. That's from the first shape. B and 12, B and 12. That's from the second shape. 12 and B, those guys are corresponding sides. And 8 and 12, they are corresponding sides. So I'm ready to multiply, cross-multiply, and divide. 12 times 12 is 144. And that's going to equal 8 times B, which is 8B. When I do this math, I divide both sides by 8, and that gives me that B is equal to 18. So I could then replace my B with an 18. So let's set up our final proportion. Again, I want to stick with this 12 because that was information that was given to me. If I use the 9 or the 18, I run the risk of getting it wrong because my math might be wrong. So I'm going to use this 12 and I need to use this C. That means I need to use the corresponding sides from the first shape. So that means the 8 and the 14. So I'm going to go ahead and put 8 over 14. And that's going to equal C over 12. So 8 and 14, first shape. C and 12, second shape. 8 goes with 12 and 14 goes with C. Notice I set my proportion up incorrectly. I have 8 going with C. They are not corresponding sides. This proportion will not work this way. That means I need to switch them around. So, checking again, my 8 needs to be with my 12, and my 14 needs to be with my C. Now I've got it set up correctly, and I can cross-multiply and divide. 8 times C is 8C, and 14 times 12 is 168. And when I do that math, I divide both sides by 8, and I discover that C is equal to 21. So I can replace my C with 21. Now I've found all the missing lengths of my second shape.